Assalamualaikum warahmatullahi wabarakatuh. Okay, so moving on for question 37. Wait. Okay. Use polar coordinate to combine the sum, which is integral of 1 from 1 over 2 set 2 to 1 and set 1 minus x square to x xy dy dx plus integral 1 set 2 0 x xy dx dy dx plus set 2 to 0 set 4 minus x square xy dy dx. Okay, so using the given integral, we can draw the graph, which is for the first one we managed to get the circle for this, which is x square plus y square equal to 1 square, so the radius is 1. And for the second we get x equal to y, which is the straight line, and for the third one we get x square plus y square equal to 4. Okay, so using polar coordinate we need to change it to polar. So then we, after deriving the what we call the limits, and then we get this for the r, we get the limit is from 2 to 1, and for the theta we get from 0 to pi over 4 or 45 degree, because x equal y, so it's 45 degree, and in radian is pi over 4. So our equation is xy. So xy, x equal to r cos theta and y equal to sin cos r sin theta. So we get our equation actually is, our equation is actually is r square sin theta cos theta, but in here we have actually dy dx is equal to r dr d theta, so we get r cube sin theta cos theta dr d theta. Okay, so continue, we integrate as usual, so we get r power of 4 over 4, insert value 2 and 1, then we got 15 over 4 in the front, and then we integrate the sin theta cos theta, which is sin theta cos theta. In the in identity we get sin square theta over 2, and then we insert the value of pi over 4 and 0, and then we manage to get 15 over 16. So for the question number 28, sketch the region of integration for the integral, which is from 0 to a, integral of 0 to a, and integral of a minus x to set a square minus x square, which is our to fxy dy dx, which is our fxy is equal to xy, same with the question before. Then we integrate it respect to y, so we managed to get y square over 2 in bracket from a minus x to set a square minus x. Actually here no square, my bad. Okay, continue. Okay, so dx, okay, continue. Then we insert the value, so we get this, and then for this we need to expand it, and then we get negative a square plus 2ax minus x square. The over 2 we remove it to the outside, and then we plus addition as usual, and then we get negative 2x square plus 2ax. We cut the 2 with the outside, and then we get ax square minus x cube dx, and then we integrate it respect to x, and then we get ax cube over 3 minus x power of 4 over 4, 0 to a, and then we insert the value, and then we get this, and this is our final answer, which is a power of 4 over 12. That's all for me. Thank you.
So for the first question, we do y equals to square root of x minus x squared. Then we square both sides and then we get x squared minus x plus y squared. From that we can get the circle equation that we get the range of radius is 0 to 1 and theta is 0 to pi over 2. Then we convert it to polar integral. X r cos theta, y equals to r sin theta, x squared plus y squared equals to r squared. Then we simplify it, we can get the limit 0 to pi over 2 and 0 to 1 for cos theta sin theta exponential negative r squared r dr d theta. Then first thing first, we integrate the radius part, that is the limit 0 to 1 exponential of negative r squared. Then we let u equals to negative r squared. Then we get the integration of e exponential negative r squared is e negative r squared. So we plug in the limit that is 0 to 1. We get exponential negative 1 minus 1. Then we integrate for the theta part. We get negative 1 in bracket negative 1 over 2 cos 2 theta. Then we plug in the limit is 0 to pi over 2. We get negative 1 in bracket 1 over 2 plus 1 over 2. 1 over 2 plus 1 over 2 is 1, so we times with negative 1, then we get negative 1, then we multiply with the integration that we get from the radius part. So the final answer is negative exponential negative 1 plus 1. For the second equation, we did the same as the first equation. So y equals to square root of 2ax minus x squared, so we square both sides and we get x squared plus y squared equals to 2ax. The range of the radius we get is 0 to 2a cos theta, and for the theta we get 0 to pi over 2. Then we convert it to polar integral. We get limit of 0 to pi over 2 and limit 0 to 2a cos theta sin theta exponential negative r squared over a squared r dr d theta. First thing first, we evaluate the r integral. We let u r squared equal r squared over a squared. Then we get r dr is equals to a squared over 2 du. Then we substitute into the equation. Then for the r integral, we get a squared over 2 in bracket exponential negative 4 cos squared theta minus 1. Then we evaluate the theta integral, which is 0 to pi over 2 cos theta sin theta d theta. Then we take it from the trigonometry identity, we get 1 over 2 sin 2 theta. Then we integrate it, we get 1 over 2 in bracket negative 1 over 2 cos 2 theta. Then we plug in the limit, so we get 1 over 2 in bracket 1 over 2 plus 1 over 2. So we get it's equal to 1 over 2. Then we multiply it with the r integral. So the final answer is a squared over 4 in bracket exponential negative 4 cos squared theta minus 1.
For the question A, the line given are y equal to x, y equal to 0 and x equal to 1. We sketch the region by using all the lines as shown FA. For the question B, we need to use the polar coordinate to evaluate the integral. From the previous, we know x equal to r cos theta and y equal to r sin theta. For the x square plus y square, we have r square and dx dy is equal to r dr d theta. So we find the limit for r and we get 0 until 1 over cos theta, and for theta we have 0 until pi over 4. Then we sub the integral with our new polar coordinates. We have limit pi over 4 until 0, 1 over cos theta until 0, r cos theta, dr d theta. And we integrate the dr first and we get r square cos theta over 2. Then we integrate for d theta until we get 1 over ln sec 2 plus 1. For the question 32, we need to find the region of integration from limit alpha to negative alpha, square root alpha square minus y square until 0, x dx dy. And we find the limit for x is square root a square minus y square. Then we rearrange and we get x square plus y square is equal to alpha square. That equation is referred to the circle with radius of alpha. From the limit y, we know that it is alpha until negative alpha. And from the sketch, we can find the region for r is on the right side of the circle. From that, we can find the limit for r and theta. For limit for r is alpha until 0, while the theta is pi over 2 until negative pi over 2. And then we sub the integration into polar coordinates, and we have limit pi over 2 until negative pi over 2, alpha until 0, r cos theta times r dr d theta. Then we integrate the dr first to dr, and we get r cube cos theta over 3. Then we integrate towards d theta, and the final answer we have 2 over 3 alpha cube.
Hi, Assalamualaikum. So we will discuss the solution for the question 33, where they ask us to evaluate the integral by transforming this to polar coordinates. So for the question, we know that y limit is set a squared minus x squared and set ax minus x squared, and x limit is a and 0.
So for now, I'm going to show you for question 34. So we are given this integral, and for part A of this question, we are asked to change the order of integration and evaluate the integral. So from or limit, you can get your range. Basically, you will get y equal to 0, x is equal to y, and x is equal to a. So you can sketch the region for this, and for your new integral, you can take a look from the sketching, and you will get that for dy it will be 0 to x, and for x it will be 0 to a. So this is your new integral, and now you need to evaluate this. So first you need to integrate with respect to y. For the inner part, you can use substitution, and if you use substitution, your range will be different now, because it will become u instead of y. So you will get this new range, and after that just integrate as usual, and for the inner part you will get this after you done integration. Next, you need to integrate the outer part. You just integrate with respect to x, and x square integrate with respect to s will become x cube over 3, and then just put this value inside, and you will get this. So the final answer will be 1 over 3 ln 1 plus sec 2 a cubed. So for next question is, we need to transform the integral to polar integral and evaluate the integral when the region of integration is the sector of circle lying between 0 and pi over 4. So first you need to change this into the polar. So basically x is equal to r cos theta, y is equal to r sin theta, dx dy is r dr d theta. So just substitute that into the original integral equation, and you will get this. And now your new integral will be this, and this is the range or the limit we get from the question. So just as previous question, first we need to integrate with respect to dr. So we have r square right here. So if we integrate with respect to r, we will get r cube over 3, and then just as before, just substitute back the value here, and after that you need to integrate the with respect to this. So you can use trigonometry identity to get this, and then just integrate as usual. And for the final answer, you will get 1/24 pi plus 2 a cube. So that is all.
So for the y limit, we have to find the shape or the graph. So for the first a squared minus x squared, we get y squared plus x squared equals to a squared, which is circle. And for the second limit, ax minus x squared, we get this one, and also a circle. So now we get this graph. We know that the region is here. So from this graph, we can find the limit and theta limit. So before that, this equation, we have to transform it to polar coordinates by we know that x squared plus y squared equals to r squared. So we just substitute it, and dy dx equals to r dr d theta. So from figure, we know that theta is from 0 to pi over 2, which is 90 degree, and the r there is 0 to a, from the middle to the side a. So we just integrate it. First, we have to let u equal to a squared minus r squared, blah 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 blah. Then we get the 1 over sec u du. Then we integrate the u, we get sec a squared minus r squared. Then we substitute the r value, which is a and 0. Then we get the a d theta, and we integrate dA. Then we get the final answer is 1 over 2a. And then for the question 36, we also have to show that this equation is equal to pi over 4. So first thing first, we know that the limit for x and y, thus we draw the graph. So from the graph, we know that the theta is from the 0 to the pi over 2. And then the r theta, and for the r, we know that it's from 0 to the infinity. And then this equation, we have to change it to the polar form. So we get 1 over 1 plus r squared, and the dy is equal to r dr theta. Then we do the integration. For the first one, we get negative 1 over 1 plus r squared with the limit of the infinity and 0. We substitute and we got negative 1. Then we do the integration for d theta. Then we get the 1 over 2 theta with the upper limit is pi over 2 and the lower limit is 0. So we substitute the value, and then the final answer is pi over 4, which we have proved that is the same with the question given. So I think that's all for the question 33 and 36. Thank you.